Welcome back. In this class we are going to discuss about Nora logic, or you can also call this logic as a zipper logic. Now just quickly recap what we had discussed in the last class, that is a domino logic. In this domino logic it is very clear that only non-complement outputs are going to be produced. That means and or like this. Let us consider this Boolean expression in this manner. Is it clear? Why? Because we know that if there is no inverter, then it becomes which logic? Dynamic logic. If it is a dynamic logic, what is the problem we are having? Cascade problem. Why? Because this is going to be activated to the other stage. Is it okay? Therefore we are keeping an inverter. Okay, because of this inverter the other stage is not going to be activated. That means here the major issue is, if the other stage is not going to be activated, even though if we didn't use an inverter, then our problem is solved. That means we can solve either cascade problem, and we can able to create a complement output also. Is it clear? Therefore the main agenda is to create a Nora logic, or to design a Nora logic. Now you can observe here how the Nora logic will works. Let us consider this is your dynamic logic. This is your dynamic logic. Then you are having a clock here. Then it is a VSS and it is VDD, and this is output of it. And let us consider it is an NMOS network. Now you are having an inputs here. Now if another type of dynamic logic is there, now you can observe very carefully. If another type of dynamic logic is there here, like this, a pi, and it is a VSS and VDD, and it may be an output. Now here the main thing is you have to observe this output should be given as input. Is it clear? Input. Okay, now if you observe that if this is not going to be, if this output should not activate this network, then our problem is solved. Therefore you just think about that. Is it clear? When pi is equals to 0, here the output is 1. Is it clear? When pi is equals to 1, it should depends on this, but in the meanwhile this 1 is going to be activate this circuit if it is an NMOS when pi is equals to 1. Are you clear? Therefore the idea is, instead of NMOS, if you use a PMOS network here, then you have to collect an output here. If you use a PMOS network here, then even though it is 1 when pi is equals to 1, even though it is activated, since pi is equals to 1, this is a PMOS network, it won't be activated. Is it clear? It won't be activated. Then depending upon this input, the output will be decided here, and depending upon this output, and it will act as input, and the output will be decided here. Is it understood? This is the concept of Nora. Nora in no sense no race logic. We do not have any race here. Is it okay? In this manner. Now tell me, if you want to connect this output to the next stage, next dynamic logic, then what should be the network? Absolutely. What is that? NMOS network should be present. I hope that are you clear? This is about the Nora logic or zipper logic. That means with this concept it is very clear for us. We successfully concluded pseudo NMOS, dynamic CMOS, domino CMOS, and Nora or zipper. Now you know we have to compare all this with whom? Absolutely. With whom we have to compare all this? CMOS. Now let us consider it is a CMOS. How many number of transistors CMOS consist of? 2n. This one n plus 1, this one n plus 2, and it is n plus 2 itself, but don't forget it must have one inverter, and it is a different type of structure for overcoming cascading problem. I hope that are clear. Now a task to you guys, please try to execute it. The question is the following design the following. That means 1 2 using A pseudo nmass, B dynamic CMOS, C domino CMOS logics. Okay, now the Boolean expression is y is equals to AB plus C whole complement. Here y is equals to A plus B into C plus D. Okay, and third one also try to design y is equals to AB, and fourth one A plus B whole complement. This is a task for you. If you are having any doubt while designing, please comment. Okay, have a nice day. Thank you very much.